Let us draw some diagrams for hybridization showing the orbitals overlapping. In that case, first we can take overlapping of orbitals in ethene molecule. If we take C2H4 molecule, how to draw in this case? The orbital diagram. You can take ethene orbital diagram showing the orbitals. Now if you take an ethene molecule, what is carbon hybridization state? If you take structure wise, we have double bond here. Each carbon atom is sp2 hybridized. In ethene molecule, each carbon atom is sp2 hybridized. So they will have one sp2 sigma bond and they are overlapping hydrogens s orbitals. If I draw this orbital diagram here, it is taken one carbon atom having sp2 3 lobes. Second carbon atom sp2 orbitals. This sp2 orbital overlap with hydrogens s orbitals to form sigma bond. It is sp2s sigma bond, and then carbon atom taken here, they contain one unhybridized p orbital. They contain one unhybridized p orbital. We can show this p orbital which is unhybridized this way. It is carbon's unhybridized p orbital. When the overlapping takes place, it is overlapping of p orbitals which are unhybridized. So we can take in ethene molecule, both carbon atoms are sp2 hybridized. They have got one sp2 sigma bond and one pp overlapping to form pp pi bond. Yeah, pp pi bonding, and then they form with hydrogens. They will form sp2s sigma bonds in ethene molecule. Now in this molecule, if we draw here, arrangement wise it can be shown this way here. It is taken ethene molecule structure wise. You can see clearly we are having one carbon sp2 hybridized each. They are taken hydrogens. In the plane of the molecule, it is plane. All the atoms are lying in same plane. So all the atoms are lying same plane. It is one hydrogen, second hydrogen. Then you can take, suppose it is the plane. Then this pi bond taken here to the plane of molecule, the pi bond become perpendicular. The plane of molecule, the pi bond is perpendicular. And then for the pi bond, they will have one nodal plane. For the pi bond, they will have one nodal plane. That the nodal plane of pi bond will lie to the pi bond. It is perpendicular. So that will lie in the plane of molecule. This last point again try to understand. See, this question was actually given once in examination, entrance examination, and can be asked frequently. And the student normally don't get this point easily. Question ये था मेरा कि आपका ऐसे ये हुआ p orbital overlapping, they form pi bonds, lateral overlapping. So what happens when it is nucleus? So when the overlapping take place, it can be taken somewhat pi bond by lateral overlapping of electrons. It is nucleus. So what happens to the pi bond? It is taken nodal plane. We can take nodal plane of the pi bond is perpendicular to the plane of molecule, and then to the plane of molecule, the pi bond is perpendicular. Pi bond is perpendicular to the plane of molecule. So what happened? The nodal plane of the pi bond will come in the same plane as that of molecule. The nodal plane of pi bond is in the same plane as that of molecule. That the nodal plane of the pi bond is in same plane as that of molecule. This question was given कि nodal plane of the pi bond in ethene molecule is lying where? Options दिए question में कि it is to the plane of molecule, it is perpendicular, it is in the plane of pi bond, or to the pi bond it is in the plane of molecule. So the correct answer was this one, कि the nodal plane of pi bond is in same plane as that of the molecule, or it is in the molecular plane. Meaning क्या होता है to the pi bond? If it is taken the pi bond, try to again see the 3D structure here of ethene molecule. It is pi bond. आप देखिए खुद यहाँ से to the plane of molecule we are having all the atom hydrogen, carbon, again carbon, hydrogen in the same plane. If it is a plane, they are the plane of molecule. To the plane this pi bond is perpendicular. It is this plane for the pi bond. So when to the pi bond molecule become perpendicular, and where we have nodal plane for the pi bond, the nodal plane will be perpendicular to the pi bond. So nodal plane of pi bond will come in the same plane as that of the molecule. That is what happens in the given case of ethene molecule. This point is important one, and in similar questions this point you can see further. Now we can take the orbital diagram for the acetylene molecule C2H2. If you take an acetylene molecule, we have two carbon atom sp hybridized each, and they have got sp hybridization. For both carbons they have sp hybridization. How to find sp hybridization? I told you one method. If the structure given to you, you can count the number of lone pair plus number of sigma bonds on the atom concerned. That x value in the table I given you. So if we know the number of sigma bonds are 2 per carbon, so each carbon atom is sp hybridized. And now when we have sp hybridized, how do we draw the diagrams, orbital diagram for this molecule? It is one carbon sp orbitals, lobes, each carbon sp hybridized. They are sp hybridized orbitals, lobes, and this is hydrogen atoms 1. It is hydrogen atom number 2, and then they will have two mutually perpendicular p orbitals which are unhybridized. So they will form two pi bonds. One this pi bond, and second this pi bond. So what we can see in this case, the shape become linear around each carbon, and we have two pi bonds mutually perpendicular to each other, and together they are also perpendicular to the molecular axis. So what happened in this case? The two pi bonds taken here, the two pi bonds, they are form cylindrical pi electron cloud around the sigma bond, and it makes them bit less reactive in reactions. If you just compare common reactions, आप पढ़ोगे आगे alkenes chapter में या alkynes का compare करते हैं कि which is more reactive for attack of electrophile, तो क्या होता है, alkenes are more reactive than alkynes towards electrophilic addition reaction. Reason क्या होता है, your point कि the two pi bonds will form cylindrical pi electron cloud around the carbon sigma bonds, which make them less reactive or which make the pi electron to be held tightly. If I try to show this in 3D structure arrangement wise, this can be in shape of acetyl molecule. We will have three bonds as a whole. It has been shown to you. Okay, one sigma bond is there and not shown here. We cannot draw properly, so I'm just drawing here this way. So you can take each carbon atom sp hybridized. Between two carbon atom they will have three bonds. They have three bonds. आपको three bond दिख रहे हैं उसमें? That is not actual view. We have one pi bond, this one here, second pi bond, this one here. The two pi bonds are perpendicular. Actual में. And then you can take shape is linear. It is linear shape. One carbon sp, one carbon sp. It is hydrogens. So they will have sp s sigma bonds for each carbon terminal, and this middle carbon will two carbon they form sigma bonds using using sp hybridized orbitals. So they have sp hybrid orbitals which form sigma bond 1, and it is sp s sigma bond sp again s sigma bond. That is what we can draw in the ethyne molecule, the orbital diagram. Now one more diagram we will draw here is alene system. In alene molecule, the orbital diagram, if I take alene C3H4 or CH2 double bond CH2. In alene, how to draw the orbital diagram? If you take structure wise, carbon hybridization wise, if I draw one simple diagram taken first here, this carbon atom is sp2 hybridized, this carbon is sp hybridized, this carbon is again sp2 hybridized, and this molecule taken here, when we see the overlapping of orbitals, this molecule become non-planar. Here all the atoms are not lying in same plane, so the molecule become what here? Non-planar. कैसे होता है आपको दिखाते हैं by drawing the orbital diagram. Middle carbons are sp hybridized. sp hybridized, carbon terminal sp2 hybridized, their hydrogen atoms forming sigma bonds. Now carbon taken middle, it have two unhybridized p orbitals. One unhybridized p orbital, carbon taken are sp2 hybridized. They also contain one each unhybridized p orbital. So it is one carbon unhybridized p orbital from one pi bond. It is second carbon unhybridized p orbitals which form one more pi bond. This can be taken alene molecules. The orbital diagram, we have two pi bonds mutually perpendicular. We have two pi bonds mutually perpendicular. So if I draw in simplified way, carbon 1 and carbon number 2 and 3. So if I take one pi bond is in the plane of molecule or in the plane of the board, this pi bond is on the plane of the board, and then this pi bond become perpendicular. The two pi bonds are mutually perpendicular, and then two hydrogen taken here to the pi bond, the atom become perpendicular. So I can written this way. They are not in same plane, but to this pi bond which is in the to the board it is perpendicular. The group will come in same plane. The group will come in same plane. So what happened? this is making the molecule what here? Non-planar. Means if I write here the atom directly here, same diagram, so we can take two hydrogen atom taken here, are not in the same plane, but the plane of the board, they become perpendicular. So we have two pi bonds perpendicular. To the two pi bonds, to this pi bond, the group become perpendicular. One atom is outer plane towards observer. It is meaning the group is towards observer. Or out of plane. Suppose your observer is towards you and this is below the plane or away from observer. Below the plane or away from observer. And they are on the plane. The two hydrogens are on the plane. On the plane. If I try to explain this by 3D arrangement, now I have taken two atom hydrogen different color. All are hydrogen terminals. It is showing what here? Okay, if we take this same diagram and drawing here, it can be seen this way here. Okay, if it is we take the plane of the board, then this pi bond is on the plane of the board. Then this bond is towards observer. It is drawn by a wedge. It is called as wedge. तो ये आपकी तरफ आपको दिख रहा है ग्रुप आपका. It is called wedge towards observer. आपका जो green atom यहाँ पे कहाँ पे है? Away from observer. On it is called dash. It is called dash. तो then it is one pi bond. It is in the plane of the board. Then to the plane of the board, the group become perpendicular, and then it is second pi bond. To this pi bond, second pi bond is perpendicular. So second pi bond will be perpendicular to the plane of the board, and then the group will come in same plane of the board. So we have hydrogen atom, two hydrogen atom on the plane, same plane of the board, and these two hydrogens are to the plane perpendicular. So this molecule will have shape non-planar. Non-planar का meaning क्या होता है? All the atoms are not lying in same plane. When all the atoms are not lying in same plane, it is called as non-planar structure. We have taken first and two cases, ethene और ethyne acetylene, they were planar. कैसे planar होते हैं? We can again see, it is taken ethene, atom all are in same plane, the planar molecule. If it is acetylene, all are linear shape, means definitely in the same plane. So ethene and acetylene were planar, but alene, which is having double bonds, even number 2, 4, they will be non-planar. If I suppose draw one more alene which is having suppose 3 pi bonds, when alenes contain odd number, alene means which are double bond continuous, we call them alenes. Alenes means they have double bonds continuously. They have conjugated double bonds. Conjugative double bonds. We call them alenes. Now if I draw alene which is having suppose 3 pi bonds, then that become planar. How? I explain to you. Now if you take example of alene which have 3 double bonds, means you can remember directly as a shortcut here. Alenes having even number. Alenes having even number of double bonds like 2, 4, 6. They are non-planar. Non-planar. While alenes having odd number of double bonds like 3, 5, they become planar. In this case, all the atoms are lying in same plane. If I take this example of alene which have 3 double bonds, you have taken last one, alene having 2 double bonds. This alene have 3 double bonds. This alene become planar. कैसे planar हुआ? अब देखेंगे और स्ट्रक्चर में. Carbon sp2, sp, sp, sp2 hybridize. So if I draw the carbon atom, we take 2 hydrogen in the plane. then to the hydrogen atoms in the plane, the pi bond become perpendicular, then second pi bond will come in the plane of the board, then third pi bond to this pi bond, third pi bond is perpendicular, and then to this pi bond the group will come in this, the group become perpendicular. So what happened? The group will come in same plane. So hydrogen all are coming in same plane, all the atom become same plane. So when it happens, it is example of alene which is having odd number 3 double bonds. This become planar. कैसे हुआ? Can see again. This can be drawn the structure of alene having 3 double bonds. देखिए इसमें क्या है? I have taken suppose this diagram here. Same molecule drawing here for your clarity here. देखिए आपका यहाँ पे एटम्स कहाँ पे है? ऑन द प्लेन ऑफ द बोर्ड. आपका ये प्लेन ऑफ द बोर्ड है. यहाँ पे एटम कहाँ पे है? प्लेन ऑफ द बोर्ड में है. देन टू दिस टू एटम्स दिस पाई बॉन्ड बिकम परपेंडिकुलर, एंड दिस टू दिस पाई बॉन्ड सेकंड पाई बॉन्ड बिकम परपेंडिकुलर. दिस पाई बॉन्ड विल बी कमिंग इन द प्लेन ऑफ द बोर्ड, एंड देन टू दिस पाई बॉन्ड द नेक्स्ट पाई बॉन्ड बिकम परपेंडिकुलर टू द प्लेन ऑफ द बोर्ड. This pi bond become perpendicular, and then to the pi bond the group will be perpendicular. So what happen if it see ultimately all the atoms, hydrogens and all the carbons are coming in the same plane. So this molecule become a planar molecule. You get an exam question frequently. Selection of planar molecules, non-planar molecules among the following. So when we have especially alene systems, when they have these two conditions, you can keep in mind this point will help you in also stereochemistry when we take optical isomerism in alene systems. So it is the drawing of some of the diagrams of the molecules by this orbital diagram using the concept of hybridization. Now one question I can take here, selection of planar and non-planar molecule. So this question is writing on the board, just fill planar and non-planar, that's all. Now one question is given to you. Question is select planar, further write P symbol, and non-planar write NP molecules among the following. ठीक है? आपको मैंने यहाँ पे कुछ I made 2 columns. In column I will put here answer P or non-NP, and here put answer P or non-NP, whatever you feel. Example दिया है पहला CO2, second BeCl2, H2O, BF3, PF3, ClF3, PCl3, SO3, ClO3 negative, CCl4, SF4, HCF4, IF5, PCl5, SF6, benzene. You can take name allenes, they are all allenes taken. Last one is ketene. For them, write the answer and try this question yourself. Now coming on answer part of this question, देखिए बहुत सिंपल है. आपको यहाँ पे जो भी आपको दिया है मॉलिक्यूल या आयन, उसका शेप ड्रॉ करना पड़ेगा. आप शेप ड्रॉ करो पहले, then you can see if all the atoms are lying in same plane, then the molecule is planar. If all the atoms are not lying in same plane, then the molecule become non-planar. You can see here. Like in this case, CO2 molecule is linear shape, all the atoms same plane, planar. So is BeCl2, SnCl2 also planar. Angular shape, for the shape we don't consider lone pair. Shape of SnCl2 is like this. Atoms are lying in same plane. You can see anyway, one plane. So is water molecule planar. BF3 planar, shape is triangle planar. PF3 is non-planar because it has pyramidal shape. In pyramidal shape, all the atoms cannot lie in same plane. If it is simplified way here, one lone pair छोड़ दीजिए, phosphorus we have 3 fluoride, तो shape become pyramidal. In this case, all the atoms are not possible to come in same plane, so it is non-planar. ClF3 have T shape. So T shape means all the atoms can come in same plane. T shape means atoms are coming in same plane. PCl3 like PF3 non-planar. SO3 shape become triangular planar. all the atoms are coming in same plane means, so it is planar molecule. इसका नाम होता है trigonal planar shape. ClO3 negative shape is pyramidal, so non-planar. CCl4 tetrahedral, non-planar. Now SF4 molecule. Now if you take SF4 molecule, the shape is called seesaw. Shape is called seesaw here. Angle slightly affected here, but all the atoms can come in same plane. Even the atoms can come in same plane. If it could have been taken trigonal bipyramidal, then not, because then the atoms will be one here and then to the plane the remaining are perpendicular. But in this case atoms can come in same plane. XeF4 shape is square planar. IF5 square pyramidal, non-planar. PCl5 shape is trigonal bipyramidal. All the atoms cannot come in same plane, so non-planar. Octahedral shape for SF4 molecule, non-planar. Benzene is planar. All the atoms lying in same plane in benzene. In allenes, when they have even number of double bonds 2, they are non-planar. When they contain odd number of double bond, they become planar. 1, 2, 3, 4. 4 means even number, non-planar. Last one is planar because we double bond only one oxygen, so hydrogens can come in any plane. The molecule as a whole become planar. Molecule as a whole become planar in the given last case. That is how in different cases you can compare. अगर डाउट है किसी भी एग्जांपल में तो आप उसका स्ट्रक्चर ड्रॉ करिए पहले. किसी भी आपको डाउट अगर आ रहा है एग्जांपल के अंदर, फॉर दैट मॉलिक्यूल यू ड्रॉ फर्स्ट स्ट्रक्चर. फ्रॉम स्ट्रक्चर यू कैन कंपेयर कि आर द एटम्स इन सेम प्लेन और नॉट. In these cases you can try to use, I given almost the given examples answer to you. You can draw the orbital diagram. For such case you draw orbital diagram involving hybrid orbitals, and then you can easily compare कि are they polar, planar or non-planar. So I hope it is clear this concept. Now for getting hybridization we can take one method more. Like we were having doubt कि pi bond ड्रॉ कैसे करते हैं, तो let us come on that next method to find hybridization using one more method called oxidation number method.